Okay, so say I wanted to make an integral to find the volume above z is x squared plus y squared and below z is 8 minus x squared minus y squared. First, what are those things?
Ellipses or parabolas.
Paraboloids.
Elliptical paraboloids.
And they are circular paraboloids.
Oh.
They make strange egg.
So they make this kind of funny egg that's got a not differentiable equator. You guys see that?
Yeah.
You all see what I mean about not differentiable right there?
Yeah.
It's got like a little corner on it.
It's a flying saucer.
So, what is your best choice of coordinate systems for this?
I chose cylindrical and it worked out really well.
Cylindrical is definitely the best choice because what do you got here that's easy?
Z. Well, Z equals and then x squared plus y squared.
There's lots of x squared plus y squareds kicking around. Like,
Yeah.
so
That's just R squared.
that's z is r squared. That's chill. And the other one is z is
8 minus r squared
8
because
minus r squared. Awesome. Like, that's going to be pretty chill. And then what's the intersection look like between these two circular paraboloids?
I think we figured out through I said by visual we figured out that r equals 2, but I think it's good. Is that what you're?
Plus or minus.
No. Easier. They're circular paraboloids.
Yeah.
This thing is where one of them hits the other, right?
Yeah. Oh,
They're
that's
oriented in
what you're
this like opposite directions.
Yeah.
So that's going to be a what kind of object? It's going to be a circle, right? You guys see that?
Yeah.
How do I figure out what that circle is? Well, shit, as far as z is r squared hits z is 8 minus r squared, right?
Yeah.
So that's where r squared is 8 minus r squared. Solve for r. Cool.
Yeah.
So I found out r is 2. So if I'm going to do this in cylindrical,
Oh.
I need a 1 r d.
I did dz first.
Yeah, you might want to start with DZ.
You definitely want to start with dz,
D theta can be anywhere,
And
so
DR,
just put it
and
there.
then dr and d theta in either order. But you definitely want to go with z next. Why does z want to be in the beginning there?
Because it's our functions basically. Z equals r squared is the bottom half, and z equals 8 minus r squared is the top half.
It's the only non-constant limit.
Yeah,
it gives you a nice.
You're going to want to go from one edge to the other, right? In whichever thing you pick first here. And so if you go from, I don't even know what the hell edge to edge in thetas means, right? You guys see that? Like this goes all the way around. So I'm going to go 0 to 2 pi in theta, and it doesn't matter where it happens. What does matter is that my r and my z are in the right order. So if I try to go r's, right? Your radii are going to have to go from the middle out to the edge, but which edge you hit depends on what z you're at. You guys see that? So you'd have to chunk this into 2 pieces to do the r's first. You guys cool with that?
Yeah.
But to do the z's first, I can just go from the bottom to the top. And they're the same bottom and top everywhere. And then I can smash it down and get that circle. And I know the radius of that circle already because I thought about it a minute ago.
Yeah.
You guys see that? So where do your z's go?
From r squared to 8 minus r squared.
Yeah, they go from the bottom to the top, right? Which is r squared to 8 minus r squared. And then your r's, they go from, so that's after you smash, right? You get a disk.
Yep.
And your disk has radii that go from 0 to
2.
2. And your thetas go from 0 to
Pi.
2 pi. Cool? Questions, thanks?
What make it 4 pi? Why not? No.
No, we can't because then we
one half times
overlap.
its integral.
Sure, I mean, you can make it 4 pi and then divide by 2. Whatever.
Yeah, you'd have to-
Right? Because if you go to 4 pi, you'll cover it twice.
Mhm.
I was joking, but yeah.
Cool?